Hi there, my name is Anar and I'm the CSC106 student at the UVic. Um, as you know, guys, I have a midterm upcoming and I thought that I should go through some basic stuff. Last time I went through, I think it was binary to decimal and decimal to binary conversions. So today I would like to look at different types of architectures. Well, computers have two different architectures. I think this guy's name is pronounced Neumann. So von Neumann's architecture and Harvard architectures. The main difference is that von Neumann architecture has only one main memory, and Harvard architecture has two memories. But before I explain you why that was necessary, let's just go through some basic stuff about how the computer itself works. Well, in any computer you have a CPU, which is a um, central processing unit. A CPU has three segments: ALU, which is arithmetic logic unit; control logic, which is responsible for. Oh, excuse me, I didn't tell you what ALU is responsible for. Well, the task of ALU is basically to perform computations, like to add numbers, to subtract numbers, really easy stuff. Control logic just decodes your machine code and again performs certain actions depending on what exactly you asked your CPU to do. Your registers are memory locations. They just contain basic information that your processor constantly needs. It may be basic. It may be just a number that you store in the register, and then you want to add it up to another number later on, and you don't really want to access main memory because main memory is slow. Register is fast, and you want to get stuff done fast. Like speed is really important when we're talking about computers. The CPU is connected to the main memory using the memory bus. The main memory nowadays is represented by RAM. RAM is a random access memory. For people who like definitions, well, according to Encyclopedia Britannica, RAM is main memory in which specific content can be accessed directly by CPU in a very short time. It's a very, very short time. Not as short as registers, obviously, but for an external memory, it's a very short time. Uh, and um, and and another thing that I really need to tell you guys is that RAM is dependent on the power supply. So once you do not supply power to your main memory, um, the whole information just gets erased. But the question you can ask me is, okay, I got it. I got that the information gets erased, and I got that it's important to store information externally. But what kind of information do we need to store? Well, basically there are two types of information that we need to store. One is the program itself. So when you write a program, that is an information, so you need to store it somewhere. So main memory is a really good place to store it. The second thing is the data generated during the process of running of your program. Like let's say you declare a variable, you assign a variable, and you have to store it somewhere. So RAM is a good place to store it, and here we have just one memory bank which stores everything. It's just a huge garbage bin. Another architecture type is Harvard architecture. Harvard architecture is pretty much the same. The only difference, it has two memory banks, one for the program and one for the data. The advantage of having two memory banks is that the processor actually just works faster because it can perform such tasks as asking for the program and then asking for a variable or another data type or whatever simultaneously, and as a result just works faster. But the disadvantage of this is that it's costly because you have two memory banks. You have to spend more money on that, and just money is important, so nobody wants to spend extra money. Modern computers found the compromise. So what they did is that they combined the features of both von Neumann and Harvard architectures. So they have only one memory bank, which is quite similar to von Neumann. But you load information from this bank to the cache, which is a fast memory. And cache memory itself has two banks, which is a data and the instructions, or in other words, the program itself. So as a result, the cache is implemented in the style of Harvard architecture. So I don't know if it was proved that this thing is faster or more efficient, But we just need to know that in modern computers they have this architecture, and if you know that, I'm pretty much sure you should be fine on the exam. Well, that's it for today, guys. Make sure you put a like in the make sure you give me a like. You make sure that you write a comment in the section below if you have questions, and obviously like if you like the video. But I believe if you watched the video till the end, you liked it, and please don't forget to press the subscribe button. See you next time, and have a great midterm. I hope you do really good. See you later.